we are solving this one, right? This is insert random and get insert delete and get random in O of one time with the duplicates allowed. So you have to initialize an object named randomized collection. Then you want some things to perform on this object. You should insert an element into this thing in just O1 average time, right? So first of all, you have to see which data structures are there, like where you can insert in O1 time. Actually, there are plenty, even almost all the data structure just O time. Like for example, vector for a stack, your queue, your linked list, your map, map like an ordered map. But yeah, but let's don't go there. But yeah, almost every data structure you see insertion is just O1. So what's the big deal? You want removal as O1. Okay, so in vector we don't have removal as O1 generally. Yeah, we can remove by indexing, but there is given that you have to remove by the value. So for value to remove, you have to find that value in this vector, and then you remove that. So that like of end time. Yeah, and again, like there are multiple options for just removing in of one time. Like what are these? For example, you can use unordered set, an ordered set dot erase, something like that. But then you can't get random, because for random you want indexing. So this is the thing which gets you to the point that when you have to get random in O of one, which means that you need indexing, and which means you are gonna using vector. So that is the breaking point. And it's better if you know that this type of question will be solved by vector, right? So first of all, let's create our vector in v. Now insertion is not a big deal. We can just vector dot push back val. It's just o1, right? Random is not a big deal. Return v of rand modulus v dot size. That's not a big deal, right? The thing which is there is basically remove, right? How you remove the from vector in just one time. So you have, for example, a vector like this, 1 2 3 4 5 6 7 8. Okay, so you want to remove, for example, actually they are giving you value to remove, so you have to remove value 3 to remove, right? How will you remove in ideally in vector? You should just find this value and then get the index and basically erase that index. There is a v dot erase, but the thing is that v dot erase works in O of n, but we want O of 1. How will we do that? So basically the best thing to do is first to get that index. How you can get that index? Okay, obviously we are not gonna iterate, so we can store that index. We can use some what we can use some space to get that index. So we are using a map to what is the mapping? Like, this is not a map, you can say hash map, like obviously, but we'll discuss about that later. The difference between map and hash map is obviously clear, and that should not be any issue. The issue is, like, what are we storing in this map? We are storing, for example, a value and a set where this of indexes where a value can occur, right? Can Where val can occur. Okay, where val can be there, right? Can occur. Now, why I'm doing this? Because why I'm doing this? Because it's a multi-set. Because there are multiple elements, right? There are multiple elements now. There are, like, for example, 3 is present at 4 indexes, or is this 3 indexes. So where 3 is present at index. What are the indexing values? You can have your indexing, or the top was 0 1 2 3 4 5, something like that. So 3 is at index 2, 3 and 4. So same value can be on different indexing. So that's why we need a map of int comma set. We'll do this unordered set in a minute, but there is no difference other than just time complexity. Actually, there is a difference, that sorted elements, like elements are not in any form. So that is the thing that you should also have to keep in mind, that okay, now For example, now you need to delete 3. How will you do that? You'll say, okay, 3 is at these places. Now which place should I delete? Actually, that doesn't make any difference. Anyone you can delete. So you can delete either 2, you can delete 3, 4. And now the thing is that this is not a set, this is an ordered set. So 4 to 3, you can expect it like that, or anything, right? Yeah, you can delete any one of them. So basically we are gonna delete like obviously the beginning element you can delete, right? Because this beginning element is also completely random. It can be anything because there are no ordering. So basically, first let me show you how I'm gonna proceed with that. So first let's make an iterator to see whether this element is present in the map or not. So map of val dot find val, right? Whether this yeah, whether this entry is in map or not, whether this value is in map or not. If it is not, if it is there, like if it is not equal to m dot end, then we need to do something and return 0 otherwise, right? And over here we'll return 1, but before that we need to do something because that's what question says. Okay, obviously this bool of a bool function, like this bool that right doesn't justify with your insert function because you are inserting, right? What do you need to return? You need to return, let's see over here, you need to return true or false. If the element is not present, then you have to return true. If the element is present, then you have to return false. Similarly, for remove, you have to say that if the element is present, you need to return true, false otherwise, like if the element is not present. So for example, if the element is present, then you have to return 1, otherwise return 0. Now if element is present, you need to delete that element, right? Like this value, you have to delete this. So for how you do that, you'll just do let's say oh. So this is basically it is the iterator of that, and you got iterator. So you can say it dot second is that your you know, this set. So you're gonna erase something from it, but before that let me just get the index, right? Let me get the index which I am deleting, right? Like pop index, let's say this in, right? You guys will understand this very clearly. It dot second dot begin, right? That's what it is. Now it dot second dot erase this in. You can erase by value and set on another set. The another thing that's important is that, you know, now you erase this from the set, but that doesn't make sense. Map is just helping out. Actually we have this vector. How will you delete that? Now you got that index of basically what index you want to delete, that is stored in this in. Okay, so in might contain 2, 3 or 4, any one of them. For example, if contains 3, so how you are gonna delete this third index from the vector? Now you got index, previously you had value. Okay, so 3, 3 sounds similar. So let's take, you got the fourth index, you need to delete the fourth index. How you gonna delete about this, right? Again the thing is saying that v dot erase that element. Now you found that index, so v dot erase that index. But the stuff about this is again O of n. So the thing about this is only one thing, that vector support O1 deletion in only one case, when you are deleting from the end. When you're deleting, you're doing pop back, it's just O1. So what I'm gonna do is that just swap my current index which I got with the, like, you know, the end element. So for example, end element in the 6, I can remove it in just O1, but I don't want to remove 6, I need that. Let me say that okay, 4 index was there, so 4 and this got swapped. Okay, index 4 and 5 got swapped. Why index 4? We got from the, you know, by doing this in, and then we know 5 because we know the vector size at the current moment, so we can get the last index, we can get the value, and then we can just do a pop back. Yeah, so what I'm gonna do is that v dot pop back, but okay, that doesn't make any sense. First, you have to bring that index over here. So you can swap map of let's say v of in comma v of s minus 1 or v dot size. Now what is v dot size? Minus 1, right? Index is that what you got. Now now you need to do something changes in the vector, like vector changes are being done. Now you need to change your map, like okay, you erase that element from this, because now 4 doesn't exist over here, because 4 doesn't exist over here, but 4 has 6 now. 6 was on 5, like for example previous entry for 6 was something like that, right? Now you need to make this entry 5. How will you do that? You gonna say that okay, my map of v dot size minus 1, whatever was that, will be erasing something like s minus 1, but at the same time it will be inserting in, which is the index. You got that right? It will be inserting that index, and then you gonna swap that afterwards. I don't think so, because that index is still that, right? Yeah, I think that's fair. So you remove that, and then you change the stuff about v dot last element, then you just swap right. That should work fine. The only thing that you have to do, if your map of val dot size becomes 0 after this operation of erasing the stuff from here, or you can say it dot size becomes 0, then you got to do something. Then you got to do something like that, return, not return but exactly, but map dot erase it. Now let's just check this out. Okay, let's make this if the map contains find val, then you're gonna say bool b was initially 0. Okay, and then insert, if the element is already present, if element is already present, then I'm gonna make this 1, and then I'm gonna return this bool. Okay, one thing I just I knew, I was like, this is the main part, that when you just gonna val dot insert what is the current element you are inserting and what is the index, that's nothing but v dot size, right? Whew. Okay, you can say minus 1 also. That's about it. Dot begin. Okay, s was v dot size. Okay, it dot second dot size. How you can get that in insertion? Okay, let's see what I am following. This is the one which I am following. Yeah. So for insertion, you just v dot push back, v dot insert this size and return that var dot size. Okay, let's do that. Return now m of, I think you have to return if, oh I did a complete mistake, like 1, and this should be 0. Now you're good to go. Gutta gutta. Now let's just actually I got many errors on some of the cases. Let's try on that, right? Why not? Let's try on that now. Let's do it. Let's do it. Okay, this was one of the major one. Renko. This was another one. Renko, and that was the another one. Okay. Oh, I got that. Insert is giving false or insert should give true. Why insert is giving false? Because that element must be present. Insert and then remove. When you removed, you erased in. You have you not done? But I erased that. What's the of erase in? So I removed the one from there, right? When I said but erase, there was only one index where it was present. It should be removed. Okay, the stuff was that here both elements were equal. Insert removal of one. You got that. Okay, this is at the last index itself. And in is equal to it dot second dot begins or erase from that and then erase from that I minus one. And so how did he tackle this? If it is not equal to end of m dot end, pre-pause it dot second dot begin, like similar thing. Erase it dot second dot begin. Okay, he removed the ampersand of this, something like that he did, or I can do by using this. Second dot erase it dot second dot begin. V dot this is equal to swap की जगह I think they did something like that, but that doesn't make sense. Okay, V dot power back, that's again the same. Does the order matters? I don't think so. I don't think so. That should matter, but instead of that you can do it over here, something like that. Order mattered, but how should the order, how would the order matter, man? Like it shouldn't. You can pass the value or you can pass that. Let's try to submit. If it doesn't work, then we'll pass it the address. And if it does, oh, it works, man, right? So that's about it. Order mattered, man. Insertion and erasing. Yeah, because when there is nothing, there is no point of erasing. Yeah, you know that after this point, it dot second dot erase means now one got one. Like it was that like it was like one was having one, and then you remove that one, right? Now now you are again removing something from this one, but that doesn't exist. So first you have to insert that one over here and then again remove. So that was being needed to be done. That's about it. Yeah, this is the line. Yeah, when the this is obviously very logical, but this the code doesn't work without this line. This line is why it's logical. When when there is nothing over here, when there is nothing over here, then you should just remove this one that exists, because now this one doesn't have anything. But where it's affecting, this is affecting here. I think yeah, it's affecting over here. So maybe we can do something like that. m of val dot size greater than 0, something like that. It did work, but insert what? Insert in. Now let's see whether it works without this. I think it should work because like that, iterate second is equal to 0, then don't need to consider it, and it is not equal to m, and then maybe we should write m of val dot size is greater than 0. Let's see, man. Let's see. Yeah, so that was the whole game. You can avoid this line by using that size wala thing, because find will give you yes it is present, but actually iske there is nothing. It's empty. So there's no need. So you can use the size wala thing. Okay, guys. Okay, guys. Bye. Okay.